Hello, my name is Daniel, and I'm an undergraduate student of electrical engineering at the Santa Catarina State University, and I'm a member of NPE. The NPE is the consolidation of a partnership between the Power Electronics Laboratories, the Motor System Optimization Laboratory, the Energy Efficiency Laboratory, the Industrial Electronic Research Laboratory, and the Research Cell on Microgrids of Alternative and Renewable Energies. This research group is part of the Department of Electrical Engineering at the Santa Catarina University. In this picture we can see Daniel on his research emulating a microgrid. Here we can see Eduardo Martins working on his final paper projecting a vector controller for a permanent magnet motor. In this picture we can see Fernanda simulating the powertrain of a racing electrical vehicle for a university competition formula. So, now I'm going to show an example of a flyback converter. This model was developed by the master student Eduardo Sovrani, and it's used in the classroom as a teaching tool. Here in the schematic editor you can see the source, the flyback, the capacitor, the load, the control, and the measurements. Inside of the subsystem of the source you can see the bridge rectifier, the inductance L1 that is to correct the power factor, and we also have the universal input for this converter. Now I'm going to add the flyback converter with internal modulator supplied by Typhoon HIL, because in old versions there wasn't the model of flyback converter with internal modulator. Inside of the converter you can set the carrier frequency and also the other parameters of the converter. In the latest Typhoon HIL software we can add flyback converter with internal modulator just by searching this converter on the library. Core coupling was used to separate the system in different cores, optimizing the simulation and avoiding the degeneration problems. This ramification models the capacitor of the output filter of the converter. We can see the block ESR that models the internal resistance of the capacitor. It was implemented different values of resistance so that the student can observe the effect of the ondulation in the voltage output. It was implemented different values of resistance so that the students can observe the effect of ondulation in the voltage output. It was implemented different resistive loads to observe the change in the duty cycle of the converter operating in the discontinuous conduction mode. The load can be resistive or a constant current source, and the capacitor and resistance was put in parallel with the current source to not have the problem of the degeneration between the switch and the current source. It was implemented the control of the output voltage. The converter can operate in open loop or in closed loop depending on the position of the signal switch 1. To operate inside the limits of the universal voltage. The controller PI was implemented in the C block by difference equations. In these blocks, we can measure the quality of the energy considering the harmonics in the waveforms. In this simulation, we used the core coupling, so it's important to open the schematic settings and turn on the option Enable Coupling Stability Analysis. Now I'm going to show the HIL SCADA. In this panel, we can enable the converter, resetting the counter. We can hear in the schematic, and enable the switching of the converter. We can define the input voltage, we can define the reference of the output voltage, and when open loop controller is selected, we can define the dead cycle. Here we can see the input measurements. Also, we have the voltage and the current of the input. In the scope, we can change the signal update. Here we can see the diode current, the magnetized current, observing that the converter is operating in DCM mode. And also we can see the current of the capacitor. We can see the output voltage and the output current. And here we can see the power quality. We can change the output resistance, and we can change the type of the load. It's possible to change the ESR of the capacitor, and if the converter is operating in open loop or closed loop.